probably going to move towards the 5 kilogram block is going to drag the 3 kilogram block.
All right. So this changes the direction of, well, from zero acceleration. We know the acceleration just, if that's equilibrium, if we double the angle, this is going to be going down. So what we're going to do is change the coordinate system. Now, if we had kept it and solved for acceleration, I would expect the acceleration to be negative. If you don't have a problem with that, we could have kept that same system. How do the force diagrams change?
The normal force would be smaller on block 5.
So we would draw the arrow smaller. I mean, are we changing an arrow? Are we adding any arrows? Changing the direction of any arrows? Why are you shaking your head no, Osama?
I don't think we can add any more arrows.
Okay, not gonna add any more. Are we taking any away?
I don't think so.
This doesn't change at all. Now, because we have this in terms of theta, this doesn't change at all. If we had actually plugged in numbers, well, we didn't know what theta was before, so that doesn't change. Let's get rid of stuff. Let's just start clean. So we got I3 hat, I5 hat, J5 hat. All right, what is the I3 hat equation?
Is it not the same equation that we had last time?
I can flip directions around.
Okay.
And the acceleration is not zero this time, or at least two of the equations.
Would it then be W3 plus friction? Since
Why? If you say that, you're saying they're in the same direction?
Yes. Because if we're flipping the direction, it was negative before, correct?
Right.
Then if we're going the other way, would it not be a positive direction?
Yeah, so up is now positive here. Are tension and weight acting in the same direction?
No, they're not.
So one of them's gonna be negative.
Gotcha.
So tension minus the weight.
Yeah. Because now up is positive, it's tension minus weight. Is equal to?
M3 minus acceleration.
All right. Sorry, what was the breakdown there? Did you just say it wrong, or?
Yeah, I said it wrong.
Okay.
Like, I was just thinking, since we flipped, you were like, we changed directions. So I was like, since we're changing directions, if we went negative last time, then it'd be positive this time.
Yeah, and this was negative last time, and that was positive. Both signs would switch. So if the way we had it before was W3 minus the tension is equal to ultimately 0. So by the changes that we made, this is not 0 anymore. This is mass times acceleration, and then those signs would switch. And so what I heard was just W3 plus tension, and let's not forget the minus item part.
Gotcha.
All right, I5.
Would be pretty much the same as it was before.
say pretty much the same, let's be more specific.
The same except the angle. Do we know the angle?
We know the angle this time because we doubled it from what it was before.
So FT minus the tension minus, or no. Yeah, the
There
tension.
seems to be a strong desire to ignore the change in the axes.
I feel like it'd be W5
Minus,
with
force
the
tension.
Yeah. But with the angle included.
Yeah. Don't forget the part that's down the right, that's the sine in there. W5 sine of theta minus the tension
Mhm.
equals,
Mass times acceleration.
more specifically,
M5 time acceleration.
yeah. The reason I want you to say M5 here is, too many students who just put M down, and then later on when they're solving it, seem to randomly put numbers into the M's, because they wrote them down all the same. One more to go.
So it'd be W5 cosine theta minus
What you're about to say, I believe would still work, but I'm trying to stick with the convention that I set up. I did not flip J hat or J5 hat around.
okay. Minus Y then. Or
All right, so you did that minus Y, and the coordinate system I set up would be Y minus that
gotcha.
equals,
Mass 5 times acceleration.
like that?
Hmm.
What's wrong with this?
We need to mark our acceleration for I hat and J hat, because it'd be different on different axes.
Okay, so I can call this, 1 and 2. But we can actually do better than that, because if we try to solve this, we're gonna run into some issues.
Well, there shouldn't be any J acceleration, right? If it's going parallel with the y-axis.
Yeah. And again, the reason why we pick our coordinate system this way, so that one is in the direction of acceleration, one is perpendicular, is so we get one of these equations equal to 0. All right, now this third equation is actually not gonna impact us because we don't have friction involved and given the parameters of this problem and no friction, the third equation doesn't do anything for us other than for some completeness. All right, so now I've got these two equations. Those are the equations of motion. What does the first S stand for?
Substitution.
Yeah. So do we have an independent formula for anything up here?
You could set them equal to tension.
That comes in the solving phase. In other words, is there an independent, regardless of the problem, do we have a formula for tension or weight, mass or acceleration or theta?
No. We have one.
Yes. Do you know which one it is? Patrick mentioned it early on in the previous problem.
Wait.
Yeah, we have an independent formula for weight. And what does weight equal?
What exactly do you mean by independent formula?
What is the formula for weight?
Mass times acceleration.
Due to gravity.
There we go. We got it as a group. This is true regardless of whatever the configuration is. No matter what, that's the formula for weight. So that's what I mean independent. These are specific to this problem. This is not specific to this problem. Alright, so we plug that into the first one. So I got tension minus M5G equals, oops, sorry, that's 3, equals M3A. And then I have W5 sine theta minus tension. Oop. Hold on there. M5G sine theta minus tension is equal to M5A. And that's just and as mentioned, I think I mentioned it before, and as Patrick sort of shot for at the beginning of the previous version of this, there are times where I'll just write mg instead of w in the force diagram, and that's fine. All right, now let's solve. How do you solve it?
And start plugging the values, you know?
Oh, you want to plug numbers into this one? Okay.
No, I know that's wrong. We're supposed to wait until later to do that. You try to set it.
Only if you're cool. So this is the test.
I suppose the next thing to do would be set it equal to a common factor, which would be force of tension.
Okay. So you want to solve for tension and then substitute, or solve them each for tension and set them equal to each other?
Yes.
Okay.
My first inclination was set them equal to each other.
Okay. So from this one right here, we have tension is equal to M3A plus M3G. And for the second one, we have tension is equal to M5G sine theta minus M5A. And then set them equal to each other. I believe that's where you're going. So M3A plus M3G equals M5G sine theta minus M5A. We're solving for A. So now what?
Well, there's only one variable we don't know here, so I guess now we can start plugging in numbers.
Okay. 3A plus 30 equals 50 sine of 2 times 36.869 degrees minus 5A. That's 2 times. I think that was the answer from last time.
Yes.
Yeah.
And 50 sine of that number gives you 48.
So 3A plus 30 equals 48 minus 5A.
Subtract 30 from one side, add 5A to the other. We'll subtract 30, do both to both sides, obviously, but you know.
8A is equal to 18.
over 8.
Are we done? And the answer is no. It's a simple thing, but often overlooked. We've done the hard part.
Meters per second squared.
There we go. Now we've answered the question. All right, let's see if this makes any sense. First off, we doubled that angle, so it's a lot steeper on the right-hand side. So we speculated that it would indeed accelerate in that direction. We got a positive acceleration that makes sense from just physical knowledge. It is less than free fall acceleration because, well, it's being dragged, so I'm feeling good about that too. We got something less than 9.8 or 10 in our case, meters per second squared. So something seems legitimate there.
Why couldn't we just, did we not know tension?
We didn't need to know tension.
But didn't we know it?
Tension changed because we changed the problem. We need tension from the last problem,
But tension's just 30, right?
not in this case. Because, well, let's find tension, since we're here. We have equations of motion right here, both with tension in it, so, which one do you want to use?
The first one.
That would make some sense. All right, so I have tension minus 30 newtons. You know what the units are. Is equal to 3 times 2.25. Tension's not 30 anymore because the acceleration is not 0. And so my tension is equal to 36.75 newtons.
So the force upward is more than the weight of the 3 kilogram box.
It better be, because from our knowledge of just the way things work, it's accelerating upwards, so the upward force should be bigger than the downward force.
Okay,
And if you really want to double check yourself, that second equation, we had W5 sine theta, which we calculated was 48, minus 36.75 equals 5 times 2.25, I guess a question mark. So if that works. So that's 11.25. And on this side, now, this doesn't tell us if the 2.25 meters per second squared is correct. It just tells us that we did the math. This was done correctly, the math part. If the equations are wrong, then, oh, that's not the right answer. Unless we got really lucky. Still flashback to high school calculus. Test problem, made 3 mistakes. Got the right answer. Questions?
I know this is wrong, but why is the acceleration the same for, never mind. Never mind, I got it.
Okay.
Well, no.
Full sign.
I just get confused by the hi-hats being in different directions, but I was just confused as why the acceleration would be the same. But it's because the hi-hat is like that over there and then this over there, so they're all both moving in line with their relative hi-hat.
Yes. Because it's an ideal route. You look like you still want to ask a question.
No, just making sure I have my head wrapped around this.
Other questions? All right. Let's see, test on Wednesday, so a week from Wednesday, chapter 4 master set. No, wrong class. Chapter 5 master set. A week from Wednesday. Chapter 6 master set. All right, so that is 9/27 master set 5, 9/20. Ten two, master set 6. And what the heck? Let's do 9/25, so that's Monday, Wednesday. Quiz on chapter 5, the homework quiz. And I believe in you. And then on the second homework quiz on 6.
You said 9:25 is quiz 5?
Yeah, quiz on chapter 5. Where I'll take 2 of the assigned textbook homework problems, change the numbers. And you shall dazzle me with brilliance. Are we in agreement on that? That you will dazzle me with brilliance.
Do over damnedest.
All right, questions up to here, because I'm gonna make it seem more difficult.